My name is John Nordstrom. I'm the Director of Quality for BTW. My background is 30 years in electronic manufacturing, everything from electronic manufacturing systems such as BTW to captive operations. Quality is the cornerstone for any organization. Quality, cost, and delivery are the three most important variables the customer needs in their operation. As the Director of Quality, I take this very seriously. My whole career is based on quality. Product that is brought in, that people give to us with our assurance that their requirements will be met all the time. At BTW, we have a quality assurance department of 5 individuals, including myself. We have a incoming inspection activity, a out-of-box audit activity, and then in-process audit. We do an optical inspection, automatic optical inspection, AOI as it's referred to. The AOI system that we employ here at BTW is operated by Quality Assurance. Our system is based around an ISO certified system, 2002, that we look at customer documentation as being a part of it, which our own BTW generated work orders, and then process sheets that we also generate that explain to the personnel what needs to be done in order to meet the customer's requirements. From there, we take areas of interest that either by contract requirement or by our quality system, as we stated, that we will take inspection data and analyze that data throughout the process to ensure that customers' requirements are made. We do a setup inspection. This is a self-inspection where an operator sets up this surface mount machines, and then a companion buddy system, another person verifies that setup. Within that process, the Quality Assurance Department also performs in-process audits where we will go over to the line at any given time, pull a product off, inspect it to the customer's drawings, bill of material, or any other requirements contractually placed on us. This is our surface mount placement lines. What's going to happen here is that the board has been kitted, brought down. The first part of the process is we label the board. In this particular case, this is a RoHS compliant label. It has our BTW identifier on it such that we can trace this board back to our operation. First step of the process is called screen printing. We're taking the liquid paste solder, we're placing it on a stencil. The stencil is an outline of all the gold pads, the areas that we want to place parts and solder to. We screen the solder paste across. The apertures in the stencil then allow the paste to go through and deposit on the pads of the board. The next step of the process, we have 3 different machines set up here. Both machines, they have carriages on both sides of the machine such that we put parts on both sides all the way through. Each machine has a particular purpose. Here we're putting discretes on, resistors, capacitors, etc. And the machine then, through a program again derived from the customer's CAD system, we develop the program, then go in and verify it. Part of our process verification as we step through the product. Every first board that comes off a surface mount line for every product gets sent to the AOI and ran through to make sure that all the parts are placed in the proper locations and the correct parts are on the board. That verifies our setup and also the machine's capabilities. This is a progressive build. We have X number of parts going on this line, this machine, and then on this machine we have another set of parts. Each carriage has a list of a bill of material, if you want to say, the setup for, in this case, machine number 2. Machine number 3, no different. In this case, though, we're putting on the ICs, the quad flat packs, QFNs, any of the leadless devices on the board. It's a little slower, as you can tell, because it utilizes a different mechanism. It picks up the part, it goes over to a camera, verifies the coplanarity of all the part leads prior to placing down. If we didn't have this functionality, we would end up having solder opens in this case, because the leads, if they're not coplanar cold plain air to the surface, they wouldn't be touching. So this machine runs slower than the other two. Our process engineers balance this line such that we get an even flow of parts out the machines. The next step of the process is we do a quick visual inspection of the part to make sure that there isn't anything obvious, that prior to going into the reflow oven, all the parts are placed utilizing the customer's documentation controlled from our document control center. We will verify the parts are placed. We're looking for polarity issues primarily and missing parts at this point in time. There is situations on products, both on Comtrol and other customers, that they're not conducive to a machine automation. This is a place where we would use, for instance, a tweezer to hand place a part on a board that the equipment could not handle. The next step in the process then is the reflow soldering. Every board has a profile developed for it. And what this does is that we try to ramp up the surface temperature of the board in a controlled fashion and such that it hits at about 212 degrees Celsius, it hits the reflow point, which turns this solder paste into a liquid form of solder and then attaches the parts to the printed circuit board assembly. This monitor here shows the value of the temperature of the set point and actual for each zone on here. In this case right here, this is a 7-zone oven. You could actually call it a 14-zone because we have top heaters and bottom heaters. In the reflow process, it takes that solder paste that was originally screened on at the beginning of the process. The parts were placed on there, ran through the oven. Now, if you look closely at the solder joints now, they're all shiny. After surface mount, we do automatic optical inspection, AOI as it's referred to. Through a program that we derive from a customer's CAD system, we develop a program and then store in the program locations, parts, characteristics of these parts such that the camera can go through and verify what we put in its memory it's finding on the board. So the advantage to that is that I can look at ICs, I can look at resistors, look at markings on the board and guarantee that the right part was put down. This takes the place of a human being trying to, under a microscope, inspect the board and identify any defects or missing parts or wrong parts on the printed circuit board assembly. Obviously, it's very fast. All right, it's very cost effective, and we utilize it on Comtrols. All product that comes down these surface mount lines run through the AOI. The next step after that is a post solder or a hand assembly operation, depending on the product. Like any product, not all product can be automated 100%. What this line does right here, after the surface mount, after AOI, we place the hand assembly parts. These are what is called as through-hole devices. The difference being is obviously the leads. Each station, in this case it's a 2-part station. We have the customer's main drawing here, and then we have our developed process highlighted in yellow showing the operator where the parts are supposed to go for each station. This station right here is actually the first station. It's a right to left build, where here we're identifying the parts. In this case, we always put in the parts that are hard to handle, are snap-in parts. And then it's slid down the process line to the next operator. We use a buddy system in our flow process where, as an example, I would build a board and you would check my work. And likewise, the next person down the line from you would check your work. So we continually are monitoring the product for proper placement of components and compliance to the customer's requirements. Comtrol, their requirements are stated in the purchase order, also within their drawings, documented notes of the drawings, along with test requirements that they place on their product. We take that in conjunction with our workmanship standard here at BTW. We use IPC 610, the acceptability of printed circuit board assemblies, latest revision, as a guideline for our manufacturing operation. In conjunction with Comtrol's other requirements, if there's anything over and above that, that's incorporated into our process and process development such that we meet the customer's requirements. The next step in the process after the hand assembly is called the wave solder line. This product is RoHS compliant. It's lead-free product. Identified in our processes as green worksheets, green signs, green mats. Again, we develop a process for the product using temperatures and speed of the product going down the conveyor. The operator places the printed circuit board in a custom-made carrier fixture. The fixture is built such that we mask off areas that we do not want solder to adhere to, and the through-hole parts that we had placed in at the hand assembly line would get soldered here. The first step of the process is the fluxing of the printed circuit board. The flux is only being applied when there's a board in the cell. It goes through preheaters. Again, we bring the temperature up of the board based on our process development such that warping of the product or heat excursions are not overtemped. Each process through a complete build of the customer's product has what is called a work order traveler. In this case, it's green. Green stands for lead-free. If it was a leaded process, it would be just a black and white type of text. This is coming off the liquid solder pot. What has happened at this point is the flux has the board has been heated, the flux volatiles have been removed and dried. When it hits the solder, molten solder, areas that are not masked off are then soldered. All the areas that were not masked by the fixture are now soldered. Now, if you notice, we have bottom side surface mount and through-hole product on here. The fixture is custom made, so the solder only goes in where the openings are at. Every customer's process is developed and the fixtures are unique to every product. The customer documents that we use here at BTW, starting from the beginning of the process, from a customer's PO, in this case, Comtrol sends a purchase order to BTW. A customer order is created that gives us the part number, current revision, and quantity required. From there, our master engineering documents are printed out. There again, the work order is attached to that work order traveler along with the quantity, part number, revision. For every operation step at BTW, there is a work order traveler resource created. That resource will tell the operator which equipment to use, what fixture to use, what program to use, anything that is pertinent to the customer's requirements. That work order follows that product all the way through to the final shipping stage, at which point the product is closed out and we store the work order for a minimum of 2 years. BTW employs other tools for process development, one of them being real-time X-ray imaging. We perform X-ray imaging on all ball grid array devices. The dark spots are actual solder deposits put on by the stenciling process, and when the part's placed and it's reflowed, we would be able to check whether or not all the balls have actually soldered. The lines you're seeing in between, that's no different than looking inside of a body. You're seeing the bones or the circuitry of the device and the printed circuit board. We also have the capability using fiber optic cameras to look underneath ball grids. Here is an example right here of different sizes of solder fines that we could look at underneath a part. We have the ability of taking a picture of this, again using in process development or failure analysis, be able to provide pictures to a customer or as proof of what we found during our analysis. BTW employs as part of its inspection process is what we call a first board inspection. After the hand assembly operation, and a highly skilled inspector takes the board, visualizes it, and then records the results on the audit data sheet. They're looking for primarily are the hand-placed components, the proper value, etc. If an error was found, the whole lot would be rejected back to the previous step to be reviewed and repaired. The next step after that is our functional test. This is where we're going to test the Comtrol 8-port device master. Again, you'll notice there is process sheets along every set of the process. Along the testers themselves, the testers are developed by Comtrol, programming done by Comtrol. An example right here of the product setup. It's going through the programming device. In this case, this particular application, it's verifying it. It just switched over. It says that it's okay, programming complete. The next step of the process then is to actually test the functionality of the product. The testing executes all circuitry of the product using loopback DB9 connectors, and again in conjunction with the PC. The LEDs, or the receive and transmit LEDs, are flashing, and the test results are being recorded on the computer. The next step of the process after testing is the PC board is placed into the mechanical assembly. Here again we have process steps across the back side of for the operator. We use both pictorial and text processes such that it makes it easier for the operator to perform their job. The board is placed into the sheet metal housing and the screws are put into place. The important thing that we emphasize here at BTW is a continuous inspection. What we try to do in all of our process development is make sure that as a product moves down the assembly line is that each step is checked by the next operator of the previous step. And we indicate that up here on the process sheets. This step right here, they're checking to make sure there's a test stamp on the board. And then some other key attributes that we want to make sure that the product is assembled correctly, and then the process moves to the next assembly step. This person here at station number 2 has an inspection sheet, again checking to make sure that the previous step has been completed. Anything particular that we need to identify within the assembly process, we try to identify in the pictorial process sheet. As an example, vents in the front of the unit, that's a requirement obviously from the customer, and we make sure that that's how the product is assembled. Again, here's an example of the inspection sheet from the previous steps, again looking for some of the obvious issues that we talked about previously, serial number labels, the actual process step the individual just went through, and then put it in the overbox, the number of units that go into each box. And also we incorporate customer requirements. In this particular case is the palletizing of the devices. They have a particular way Comtrol wants it set up, and BTW accommodates that by incorporating it into our process sheets. The last step of the process is the packaging. Again, at BTW, as our lean journey begins, we are putting all of our processes in line. We have self-inspection. The operator in this particular packaging station puts all the peripheral data together, inserts it into the final pack box along with the unit, and on the unit she would verify that the previous step was done. Customer product testing is a unique feature within BTW. We have the capability of test development and also taking customer test-generated platforms and utilizing within manufacturing. We would look at that product from the test data and try to analyze that data and look at where we could improve our processes on a continuous basis. From a sampling standpoint, we use an AQL sampling process. Depending on the sample size, we determine what level of inspection we're going to perform, whether this is incoming material or in process, or for that matter, final. Depending what our history is, we do take data again on first pass yields, and coupling that with customer issues, we will determine if we want to do a tightened inspection or loosen up that inspection depending on the product we're working on. The board we're standing in front here is our communication boards to all employees. It has a number of things on here, primarily generated and maintained by quality assurance to communicate quality, cost, and delivery of our product, in conjunction with some metrics that we track for all customers on a monthly basis. Here at BTW, we look at the top 3 defects within any inspection point or category. And what we look at there is that, okay, how many defects were there? We drill into that. Was it something that shows a trend, something that we can go in and by altering the process, either pictorially or process development-wise, we can fix, and reduce that occurrence of that defect. The corrective action system, or we refer to as CAPA, corrective action preventative action system, is action is generated anytime a customer issue is reported to BTW's Quality Assurance Department. As Director of Quality, I take a great deal of pride in the product we ship to our customers. Continuous improvement is one of the cornerstones of our operation. 15 years ago, this company was started with 5 people. We currently employ 80 people in a one-shift operation. We have upside for capacity. We have the people that are dedicated to the operation. We have an owner that thrives on quality and delivery. We deliver it faster, we deliver it better, and we deliver it at 100% acceptance.